picking melons. Okay, so hopefully you've read the problem, and so you see that we have some information. We're told that the melons average 22 pounds at the first store and 18 pounds at the second store, and they have some standard deviations. So the question A is asking us, what's the mean of the difference? So we could just say, well, mean of the difference, so that's the expected value of, let's say, the first, and we'll subtract off the second. So we'll define two random variables. The first is the weight, the average weight, or the weight of a randomly selected melon at the first store, and S is the weight of the randomly selected melon at the second store. So that's just going to be the expected value of the melons at the first store minus the expected value of the melons at the second store. So that's just going to be 22 minus 18. So that's 4. Okay, and then what's the standard deviation? Well, the standard deviation of the difference of these two random variables is the square root of the variance. Okay, so let's find the variance, and then we'll just plug it into this formula. So the variance of a random variable, the difference two random variables, is equal to the sum of the variances of the two. So we have to add. Okay. Okay, so I think it's on page 380. On page 380 you'll see the formulas, and the formula we're talking about, I think it's written like this: x plus or minus y is equal to the variance of x plus the variance of y. Okay, so we always add, no matter if we're subtracting or adding, we always add. So this is just going to be the standard deviation of the first squared plus the standard deviation of the second. The second one was 2 pounds squared. Okay, and so I'm going to take a shortcut. I'm just going to plug that in here. Whatever that number is, I'm going to cheat because I already did it. And so I'm just going to take whatever that number was, plug it in here, and we're going to get a standard deviation of 3.20 pounds. Okay, so we'd expect the difference to be 4, but it's got quite a standard deviation, a pretty large standard deviation. Okay, so now the interesting thing is they say that if a model can be used to describe the difference, so if the model can be used to describe this difference here in weights, what's the probability that the melon you got at the first store is heavier? Okay, so what they're asking us to do is they're saying if the difference follows a normal model, so I can't draw very well with this electronic pen, so I'm going to do the best I can. But so that the difference, the center of the first minus the second is 4. Okay, so it has a normal distribution with a center of 4 and a standard deviation of 3.2. Okay, now they're saying that if it follows a normal model, what's the probability that the first, so what's the probability so that the first is greater than the second? Okay, so that's one way you might be able to think of it, is that's what they're asking us to find. Okay, the probability of this. Okay, that might translate nicely for you. But to get it into this form here of s minus s, I have to subtract s from both sides. So that would be this expression. Okay, so I can translate this. Okay, now maybe you see it. You don't have to do this, what I'm doing, but one student that I was working with translated the language of the problem to this. And so, but when we express it the way we have with our random variable, now what we can do is we know that to translate to the standard normal model, we use this expression. Okay, so z is going to be 0, so that's our value of interest. So I'm not quite sure where 0 is, but I think it's got to be over here. If this is 4 and we subtract off 3.2, what this is going to be about I think it's going to be 0.8, something like that. So 0 is going to be right about here. So we want to know the probability that it's greater than. So that would be all this area in here. All right. So our value of interest, our observed value, is 0. Okay. So we plug in 0 and we subtract off 4, the mean, and we divide by 3.2. Okay, and that's going to be a negative 1.249. So this becomes, what's the probability that z is greater than a negative 1.249. So we can do that with our calculator. I think it's called second distribute, and you find normal CDF, and we want to go from negative 1.249 to infinity, so we'll approximate that with a bunch of 9s. Okay, and then so what we get is 0.894. Okay, so to properly answer the question, we would say something like, according to the model, the normal model, the probability that a melon from the second store, the melon from the first store is greater than a melon from the second store is 89.4%. Okay, so sorry I'm a little sloppy there, but I didn't want this video to last forever. Okay, so you can see all we're doing is translating and finding the center of the model and the standard deviation of the model, and then we're just finding the area underneath the curve. Okay, so give that a try, and good luck.